Alright, so we're going to talk about our double angle formulas today, and on our other videos we showed why this one was true, and so now that we know that this one is true, this cosine, our sum formula for cosine is true, we're going to use that one to get to our double angle formulas. So what I'm going to do is the same thing I did to get to our subtraction formula, basically. I'm going to change u to something else. V to something else, or u. It doesn't really matter, I guess. But I'm going to let v equal u. Now, again, we said before that, we can change it to anything we want because it's a formula, so I should be able to change it to whatever value I want. So I'm actually going to change it to this. U plus, and everywhere I see v, I'm going to stick a u. And so what's going to happen over here is this first one is cosine u, that stays the same, and this one becomes cosine, well, u, because it's the same thing, right? And then I'm going to do sine u, sine, well, the v becomes a u. And now hopefully from here you can see that this one is cosine to u, where that's where our name comes from, double angle formula. It's 2u now. And I'll put parentheses just to make sure it's clear. And now we have cosine squared u, because now it's cosine u times cosine u, minus sine squared u. And this is our formula. Now this one, sometimes you'll see it written different ways, especially when you're verifying identities and such. You might want to see it in a different way. So sometimes what they'll do is they'll take the cosine and they'll replace it with 1 minus sine squared u. And if I have another minus sine squared u, obviously this whole thing becomes 1 minus 2 sine squared u. So sometimes you'll see the formula written this way. And if you can replace the cosine, then it's easy to kind of imagine that you can also replace the sine. So if I want to replace this one instead, I'd keep my cosine, so cosine squared u, but I would replace this one with 1 minus cosine squared u. And hopefully from here you can see that I would have cosine minus a negative cosine, so that would be 2 cosines, in other words, minus 1. So this is another way you may see the formula and another way that we use it. So these three are the commonly used and commonly written double angle formulas for cosine. So of course we could use that same principle to find our double angle for the other ones also. So for sine, our sine of u plus v is of course sine u cosine v plus sine v cosine u, and I'm going to change it to sine of u plus u. So to be sine u cosine u plus sine u cosine u. So I've replaced the v's with u's, and of course everybody knows that that's 2u then on this side. So there's my double angle that we talk about. And here we get a sine u cosine u, and a sine u cosine u, so that gives me a 2 sine u cosine u. And this one we don't usually write any other ways because, it's easy to replace a cosine squared with something else, but to replace a cosine with something else is really not as easy, right? So we usually just write that one. So the last one would be tangent of u plus v. So we'll write a tangent of 2u in a second, but tangent of u plus v, we all remember, is tan u plus tan v over 1 minus tan u tan v. So we saw those ones in our other video. And from here again, I'm just going to replace it with tan u plus u, and that's going to be tan u plus tan u over 1 minus tan u tan u. And when we simplify, well, maybe I can do it this way, sorry. When we simplify, we're going to get tan 2u, which is the formula we're trying to write, and it's going to be 2 tan u, 1 minus, this time it's tan squared u because we're multiplying them together. And there's my double angle for tangent. So once again, just to recap, there's my tangent. My sine is going to be sine 2u was 2 sine u cosine u. And cosine 2u, we wrote a couple of different ways. It was cosine squared u minus sine squared u, which we said is the same thing as 1 minus 2 sine squared u. And we said that's also the same thing as 2 cosine squared u minus 1. So those are my double angle formulas for sine, cosine, and tangent.